Hello, everybody. So today we're going to do something really interesting. We were requested to create a flow which doesn't do much, but kind of tries to simulate what a normal flow would do without impacting the server, right? So it's a good testing ground. And we're just going to overview the whole process of flow creation from start to finish using some normal practices, let's say not the best practices, but normal practices which would get you going. And of course, if this is new for you, if it's a new concept for you, then yeah, it's a good place to start. It's not for advanced users at all. So how do we do it? We spin up the studio in projects. We have the class button, click on class, create the flow. This is the name that I chose. And we have the base, which is, well, from the dependencies pack. This is all of the building components of the OO flows. And we're going to touch it in a second. So we're going to our flow that we built here in the project, and we need to set up the project structure. So first thing in the library, we create a folder named flows. And in this flows, we're going to create just a flow. So what is it that we're doing that is not a best practice at the moment? The problem is that when you have complex runbooks or complex flows, you want to build a one master flow which would go and address each and every step separately if a step has some kind of a logic. So for example, you would like to check if there is enough disk space on a file system, then return the result, then go and copy the files that you want and verify that the copy was successful. Then you would go to a third step, which would go and deploy something from the files that you copied, right? So those would be three subflows. Think about like folder structure, right? So there you have the main folder and subfolders inside. So flows can have the same logic. The top flow, this is the one that we created right now, can address other subflows. And we would normally create in the library a new folder named subflows, something like this. Now, it's too complex for a beginner, so we're going to start with the regular flow and components inside it. Now, a couple of things that we need to address. Here in the base, and you can import many other parts to it, many other runbooks from the marketplace, but the base comes out of the box. And you will have in the library, you'll have many things, operations and flows. So for example, if I drag and drop this subflow here to the canvas, then I will have a flow and a subflow inside it, right? But you also have operations. Operations look like this, not this one. But for example, yeah, so this is an operation, this is operation. They basically have a single action. So flow or subflow would have several operations inside it, usually, or at least they would be prepackaged in a subflow, but the flows themselves, they are the building blocks, right? So let's say those are the files in your subfolder, right? Okay, so we want to know which ones of those we want to import really. And since we are going to emulate some kind of an activity, we need to bring something simple and then progress from that point on. So we are going to run this flow on a Linux cluster. So we will try to use network. And I want to verify, well, is this ping good enough for me or not for my purposes? And here we touch an interesting subject. So how do I know which of those operations I need? I don't, right? Although if you learn the process of creating the all run books, it's going to be plus minus relatively similar in all situations. Knowing the components is something that you need hands-on. You would read documentation, you would browse around, look around, maybe look for suggestions from here and there. But yeah, it's like, I mean, I can teach you to go to the supermarket, but you need to know which products are inside by looking at them. It's the same concept, right? And you do it by double clicking each one of them and see, well, what kind of inputs it has. Can I work with that? Do I have all of those mandatory inputs? Do they get from someplace else? And they're pretty straightforward. I mean, passwords, target hosts, protocols. Yeah, it's pretty normal. And then you have the outputs. So you also want to know, well, if I'm going to use it as a building block, is it going to output some result which I can use later on someplace else? Sometimes you do, sometimes you don't. Depends on what you need, but you need to verify it. And then in the description, always read the description, right? And see what it actually can do for you, because it has at least a definition, and then how to work with the input. Sometimes it's not straightforward, and they provide information about doing it here, well, in the file. So it's kind of okay. And then the response and the return. So all of those things you would like to know before you import it. And seems that ping is good enough. So you know what? I'm going to bring it. Now watch this. That's it. I have it. Now, as you see, it has like a notifications as well. Ping has no outbound transitions and doesn't mean much. So we're going to address it. What we need to do, we need to drag and drop a result, which is basically the result. It's the most simple one. Now, as you see, it has a success and a failure elements to it. I'm not going to do anything with the failure. If it fails, it fails. So then I say, well, right click it, toggle single response. And it means that it's gonna be dealing only with successes. Now, as we said, we're going to have several steps over here, but I like to test each and every step in a debugger before I make it more complicated, right? Because, I mean, if you just you bring too many moving parts, you don't know where to start to troubleshoot. So it's a little bit easier like this. So now let's discuss an important point. The operation orchestration runbooks can be triggered externally, or well, they're always triggered externally, but it can be done through OO or it can be done by an automation. Now, automation, when it runs a runbook, it would provide several parameters or several variables, for example, the host name to the OO runbook. And the placement of those variables plays a crucial role. And when you run it manually, whatever variable is missing, you would have a little bit of a pop-up which would say, well, you know what, this is a parameter that I'm missing. Please provide it. It's not an option when you run a process in the background using some kind of an automation. You want to leave it unattended and fix stuff for you, right? So how do we do it? We need to set a little bit of definitions here. So when I double click a component, let's say an operation or a subflow inside the canvas, you'll see it kind of pops up from the bottom here, and I'll see all of the inputs and outputs of this specific component. If I'll go to properties down here, as you see, it opens on a full page, and these are the properties of the actual flow that contains all of the others. So previously we had the canvas, so it's actually a container, and the properties of this container are here. So let's do it once more. This is a property of the component, and this is a property of the whole flow. So when an automation runs this runbook, it would work only with the inputs of the main flow. So components would get all of their parameters from the main variables, from the properties over here. The automation wouldn't have a proper or convenient access to the components inside the flow itself. So this is where we begin. So we're going to do some kind of imitation of activity on a Linux server, right? So we probably would need a host name, and we would need a username. So I just click on the plus every time. Username. Let's keep it with capitals. I like capitals. Of course, if you're building something really complex, probably the variable naming should be done according to some more a current convention, according to what year it is. But since we're not doing something production like, or I don't know, so and maybe we will check some kind of a path on a file system. So we're running a Tomcat server over there. So I'll just give a path. Oh, sorry, no, it's going to be a path. Okay, so here's the interesting thing. If you are working on a smaller screen size, something here is missing. And if you scroll to the right, there it is, assigned to. And this is very important. So why is it important? We are determining where this variable or this input gets its data from. And since this is the entrance, this is the first thing that we meet when we run the flow, we will use either prompt the user or we will use some kind of a constant. So for example, the path, I'm not going to change it. I'm going to use a constant. It wouldn't change. So it's going to be opt slash tomcat. Yeah, just keep it like this. Now, for hostname, I would like the user to prompt us, but I'm not going to set it just yet to prompt user. Why? Because during the debug, I'm gonna do a lot of runs, right? So I'll use a constant and I'll just put a mental note to myself before I publish it to production. I need to change it to prompt users. So I'm gonna work with a server named AOS one, no, AOS 3. Of course, the username would be the constant of root, and the password it's gonna be a actually sensitive data because I want it to be a password, right? So let's make it a little bit slower and this tab a little bit smaller as well. I just don't know. I want to see everything, but I don't want to lose functionality too. Right. Something along those lines. So assign value, as you see, it prompts me for a password type of an input. So how cool is that? Fantastic. Now, I also want to say, well, this is required. You cannot skip this, right? So if it doesn't exist and you actually need it, it would skip and not prompt the user or at least notify you about something. And if your flow does something very important and you miss the required part in the middle, it might just go without parameters and ruin your database or something. So make sure that the required is set where you need it. Now, of course, we set those constants, but we need to assign them to variables as well, so it would be able to pass it later on to other components. So we are assigning it to hostname, and we're going to assign it the username to username. Of course, as you see, it's very convenient. It just gives you all of those options by itself, and there's the path. So we assign it to those variables. And why it's important? Because sometimes you would like to use variables inside some kind of a string as a variable, right? So for example, oh, I made a mistake. It's not Tomcat, it's Tomcat, right? So let's say inside the Tomcat there is a username, some kind of a folder that belongs to a username, and I want to import it. So you're gonna do those brackets, right? I think it's like this, right? And you're just gonna put username or something, and the lower or uppercase thing is very important over here, but variables can go inside. So you want to assign it to. Fantastic. So now we'll go to our ping and we'll see what's going on. So let's read the description. Hostname or IP address of the host computer where the ping command will be executed. So basically this thing, what it does, you can determine that a certain machine in your network would ping other machines. It doesn't need to be the OO server. It can be something else. And you know what? I have just the perfect server for that. So the constant would be master, right? Master and the domain, of course. And why master? Because everything master connects to everything. This is the Kubernetes cluster, so it connects to everything else. So I would like to know if there is some networking problem. The first thing that I would like to know is my main server able to communicate? Because if I experience networking problems, main server might not. So I would like to exclude it, right? Fantastic. Username and password, well, those come from our inputs, right? And it's going to be host, oh, sorry, no, it's going to be username, right? Assigned from. Password, assign it from password. Target host. So this is going to be the host name. And as you see already in variables, we are kind of went in a different direction because here hostname refers to what is pinging and target host is what gets pinged by host name of this kind. And in our variables, I just said host name. So now you see variables matter. They need to be very descriptive. Now, protocol, prompt user, well, we're gonna test it at least once. Packet size, we don't care, we don't care, we don't care. So there are no other options over here. So it's time to save and see if it works. So we click on local connection and we are going to run our debugger. So let's see, and it says protocol local. No, it should be SSH. Continue. And it's actually it's able to do something. Where's my result? Well, ping is complete. Right. Raw result and execution did not valid did not receive a valid input for remote OS. Okay. Did we even have the remote OS parameter over here? There is no remote OS. So remote OS use the constant. Okay, maybe in description we should read what it says. And remote OS operating system Windows Linux. Okay, so it can be Linux in capitals. Okay, good. Linux. Save. Test run. Click the reset button to start from scratch. And yeah, the protocol is still SSH. We're gonna change it in a second. Let's see if it runs. Okay, and primary result, auth failed. And primary result over here, auth failed, unfinished. So everything failed. Why? Why did it fail? We don't know. We don't know. So we need to verify what's going on with this thing. Why is it? Okay, so hostname is master. We got it. IP version 4 key file. We're not connected to it. This is the password that we used. Protocol, SSH, remote OS, Linux, target, host, username root, new, okay. Step context, doesn't really matter. Okay, so doesn't look very different from what we would. So auth failed. Maybe I made a mistake in the password. We don't know. Let's give it a try. So here's the password, assign value, set the password. And yeah, so welcome to the wonderful world of developing stuff. And it seems that this value didn't change at all. It just didn't. So let's run it step by step. Right. Okay. Go to this step. Right. Go to step. Yeah, we don't want it. Step over. Step into. Let's see what it means. Okay, we're going into the ping. Go to the step. Let's see what it got. Just doesn't do anything for us. Okay, and we'll go to step into protocol, local. You know what? Let's do local. Yeah, okay, okay, nothing happened. Oh, there we go. So local protocol works. Return result, and yeah. So local, it means that we. So the local worked and the SSH didn't, and we actually don't know much about why. Let's just run it once more. And we'll say I want it to be SSH. Continue. Let's see, and primary result, nothing, return step, auth failed, and we don't have, okay, we do have auth failed, and let's see why. And this is how you basically investigate and see what's going on. So you know what? At this point, since I'm not really required to be precise in my flow, I gonna keep it on local. So we are going to go back to our ping over here, and in the protocol, we are going to use constant of local. All right, let's just run it one more time before we decide that it's good enough. So we reset and we play it, and if it, oh, okay. Yeah, so we need to stop the prompting for that part. Let's give it a second. Yeah, we have a result, and we are going to change this to 4. So packet size protocol, yes. Protocol, yes. Timeout. It's a little bit. Let's drag and drop it a little bit to the top. Yes. Oh, come on. Yeah. Okay, IP version, prompt the user. I don't want to be prompt. I want to use constant, and the constant is 4 because this is what we used before. Okay, fantastic. Save it, and we know that it works. Now let's do something else. We'll delete this connection, drag it here, and we will go and try to run some other utilities. For example, a port scanner. Port scanner, port ping. Port ping, okay, so we have a port ping. Let's see what kind of an input it gets. So we would like to know, well, basically port ping is kind of a telnet verification. So you know what? Yeah, I like it. I like it. Port ping sounds just fine with me. So I'm going to convert it to a single response, and I'm going to connect it here. So we are doing here a sequence of events, right? So let's assign the same host name, and the port, well, we are not going to prompt the user because we want to use a constant. It should be running unattended, so why not? Oh, port type, I'm not even sure what it means. Timeout, yeah, we don't know doing that. So local connection, yes, save, run. Come on, there we go. Run it. Run, 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 run. So there we have the ping. It takes a little bit of time. And then we have the port ping. So the port ping says, yes, successfully connected. So there we have the other flow. So as you see in the second one worked much faster than the first one. I'm going to delete this connection, and let's try and do something on the operating system, right? So we will go, we will see on Red Hat, which is CentOS essentially, disk and file operations. Do we really want to do disk? Delete file disk metrics. You know what? Disk metrics. No, you know what? Not delete disk metrics because we didn't verify. Let's see disk usage. Remote command, double click it. So basically it says df-k, it just checks the disk. I like it. So we have already 4 commands, and it takes them about 10 seconds to run. So we are almost done. You know what? I pretty much like it. We connect everything to the result, so it would work over there. So we go and have a host name. Now let's read the description. Host name of what? Detail, no description. Description says host name or IP address, basically the remote one port. It's okay. Username, file system, password protocol, telnet, local, yeah, timeout, PTV, okay. Well, let's give it a try. So the host would be host name. Username would be username. Password would be password. File system, prompt from the user. So I'm not really sure what it's gonna prompt me, so let's wait for that. And port, use the constant. What constant is it? It's okay, it's not required. Protocol is gonna ask us a flow variable protocol. Yeah, we don't know which protocols are that. Probably SSH or something, but we need to try it with SSH or without SSH. So protocol timeout, private key file. So we're not using any fancy stuff. for communication. It's not AWS or something. So we are going to return to our local connection and run it. Let's see. Okay, so file system NFS, ext3, ext4, and protocol SSH. Okay, I'm a little bit worried about that one. Okay, there we go. It failed. Empty transaction description. What happened? Authentication failed. So it happened to us before, right? And you know what? And then, of course, the disk usage wouldn't work because the authentication failed. And why does it fail for us every single time? Probably because we need to provide the details a little bit differently. You know what? Let's try and verify. So the authentication fails like every single time. So we're going to do not assigned. And then we're going to do not assigned for username. And for password, we're going to do not assigned. Okay? And we're going to say also prompt the user for password, and prompt me for hostname because I want to tell you what the hostname is. So save, trigger. Let's see what's going on. Let's see what's going on. Is it good? Is it not good? Host. Okay, it's gonna be AOS3, right? Value for username is gonna be root. Value for password, the password. Oh, I know what happened. I know what happened. And here is an interesting thing that's completely unrelated to what we've done so far. So when you run multiple environments with multiple credentials but similar setups, you know what we need to remember? Which environment you are in. And yes, so this password is completely wrong. And yes, there we go. We run with it, we save it, and let's give it a try. So we were about to do something really interesting, but it's okay. Yeah, file system, we still need to ext4, hopefully. Is it? No, empty transaction description. ext4, no such file directory. We need to read what kind of file systems are supported. So we'll go to the disk usage documentation, description, sorry, and see. So file system to check on, file system to check on. Okay, mount point. You know what? Probably this is a slash. Probably this is a slash. So let's give it a try. Let's give it a try. So we're running file system slash. Probably it means something else entirely. Continue. Is it a slash? Yes. Yes. Okay, so now we know what to feed it, right? So we are going to the inputs and we're going to say, well, you know what? Protocol, use constant SSH, and file system, we're not going to prompt the user. We are going to, you know what? We're going to use the path. We're going to use the path. We set it somewhere, right? So let's see how much space is taken by that part of it. Let's see if it can read inside the folders and give us the size of the folder. It might not. It might fail. Okay, disk usage. How much disk usage is done? No, it just gives us the whole file system, which is completely fine, but we use the variable not for nothing. So we have all of those steps, and you know what? We will also run a command. All right, process operations, OS and server operations. Current time, get OS, not get package version, reboot server. No, no, no. Run command, trace route. So we're gonna use the search option and we say, well, you know what? Remote command. Do we have the remote command? Protocols SSH command. Let's bring it in, mark it as a single response. We are going to delete this relationship. I'm gonna put it here and attach it over there. As you see, it becomes very clean, right? No, not it isn't. Okay, let's see what we got in SSH commands. So in the description, we say host remote machine and then SSH. Yes, 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 yes. Okay, and then, okay, fantastic. So the remote host is going to be this host. Port, constant 22, username. Yeah, we're going to use the username. Password is going to be the password. Proxy host, no, 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 no. Do we have other prompts? No, we're not. So, timeout, keep alive, use global context. So, SSH command, but what is the command? Advanced, no. Scriptlet, no. Description. So, it's gonna execute a shell command, proxy host procedure, private. Choose add policy. We don't have the valid add default ETF, keep alive, default value. SSH no host. Okay. So it looks a little bit interesting. So I have the host, the port, the username, the proxy host, proxy port, proxy username, private key file, about ciphers, command. Oh, there's the command. Okay, prompt user for text. No, I'm not going to use this. I'm going to use the constant. And the constant that I'm going to use is systemctl status tomcat. Okay? Yeah, just like that. Okay, status tomcat. Yeah, that's gonna be good enough. So let's give it a save a row and reset it. Wait, let's see what's going on. Is it working? Is it working? Oh, yes, yes, yes. Step SSH command. The known host file couldn't be set. I don't even know what it means. The known host file is a known host, the system. So why do I need them? Oh, there was some reference to this in security, right? Yes. So in the description there was proxy host. Yes, private key protected. Okay, so let's see. Let's see what's going on over here. Okay, nothing really. Okay. Hidden inputs. Known host path. Specify the path to known host of the file. Examples. Default value. Allow expect execution of some protocols. Common operation for this. Allow expect commands. Default value. Okay. You know what? Allow allowed. Keep commands, character sets, private key file. Use the constant. Known host policy. Strict. No, it's not going to be strict. It's going to be nothing. Description. Known hosts policy, right? Where is it? Where is it? Default value. Known host policy. Allow. All right. So we need to set allow. And this is why you write and read documentation. Words of wisdom from yours truly. I read help files. So now we run it and we have the allow. So as you Imagine we're not running very securely, but also our environment is completely isolated. Okay, so SSH command is complete. And it actually, yeah, it returns everything that we need and it looks completely fine.